I'm Nandakumar Aparsamy from Group 5. I'm going to present the Airline Neo4j project. So basically, we are analyzing the airline data using Neo4j, where Neo4j is a knowledge graph database. We are going to use that to derive insightful information from the data. So starting with the dataset. So we got the data set as a DAT file. We got these files like airlines, airports, countries, planes, routes, all these related details. And by pre-processing the data using Python, we're just converting, basically we are formatting the data from a DAT format to a CSV file. And which is formatting in such a way that it is easy to handle in Neo4j by identifying the respective columns and all those stuff. So this is a Python file for it. We are using pandas to do the operations. And this is the formatted data where you'll be able to see on your right. In terms of airlines CSV, we have the airline ID, name of the airlines, alias, and other related details like origin, the airline based in which country, whether it's active or not, like those data. Whereas in terms of airport CSV, we have airport ID, name of the airport, city, country, latitude, longitude of the airport location, altitude, time zone, all the other details. So in country, we have list of countries along with the ID, unique ID as well, so that we can use that because that ID is used in other different CSVs as well. So planes, we have plane details like what is the plane brand is, what model is it, something like that. So and lastly, a route CSV has the details like airline ID, source airport, source airport's ID, destination and its ID, and all those stuff. So for now, we got the data, we found the data, and we pre-processed the data by formatting in the required format specific to our project. So we formatted into CSV file. So next, let's go to Docker. Because why I use Docker is if we are containerizing the images or the databases, it is easy to scale and it has less conflicts while migrating like that. So now if you see here, this is the Docker image Neo4j Airlines. I'll start this. So it will take a minute to start up. And so for setting up the Neo4j Airline container, I pull the Neo4j image, the latest image, and then I basically created the container by mapping the volume as well because I need to use the data from the system. So I map the data to the volume, and this is the URL and also port configurations as well are made along with the authentication credential details as well. So now let's jump into the Neo4j Docker container. So the Neo4j Docker image is hosted in 7474 port. So basically localhost 7474. So once you are here, we are just into Neo4j. within the Docker container. So I have written few queries earlier. I just saved it in the favorites so that I can run it quickly. And before that, once the container is set up and running, and you entered it, so we can load the data by load statements, and we can create the nodes as well. Let me show you the command. So basically, this is how we loaded the data. Load CSV with headers from this particular file as rows, and we are creating nodes by create statement, by creating the node and along with the other properties. Same applies for the other CSAs as well. So since we already loaded the data, let's directly jump into the querying. Now let's start with airline count. This basic analytics, so like the count. Okay, so this statement, this query is returning the total count of airlines in the data set, which is 6,162. And now let me go with the second one. Okay, this one is airlines based in different countries. So basically, if you see here, there is a knowledge graph visual, right? So if you see here, each cluster is a collection of airlines related to a country. Now let's take this one, this cluster. So if you see here, Brazil is a country. So at your right, you'll be able to see the node labels and the relationships of this graph. So node labels available in this graph are airline and country. So the light brown one is the country, which is Brazil in this cluster. And then the orange ones are the airlines. So these are the available airlines based in Brazil. So for example, Brazil has Brazilian Army Aviation and others which are able to see. Same applies for other countries as well. So now let's go ahead with the third one. So the airport count. So this query returns the total number of airports available in the data set, which is a basic one. Now let me jump on to the other one. So this query, that is country connectivity network, basically represents the source country and the destination country along with the number of flights available in that route. So for example, from United Kingdom to Spain, there are 518 flight routes are there. So which is from this we can derive that it is easy to get a flight from UK to Spain, and followed by other examples. So I just sorted it by designing order based on the flight route count. And moving on to the next one. So basically, this equipment and route usage, this query shows the type of planes which are being used in how many routes. So basically, Airbus 3 A320 has been used for the most routes, followed by Boeing 737-800, which is the second highest number of count. So basically followed by others. Basically I sorted it based on route count. Moving on to the next one. So it'll take a minute or two because it involves complex building of graph knowledge database. So it has so many different nodes and relationships. So it need to traverse through all the nodes. In the meantime, let's go ahead with trying others. So plane count. So basically, we are having 246 different types of planes. That is like Airbus 737, sorry, Airbus A320 or Boeing 737, like those kind of planes. I'm skipping this for now. After this ending, I'll run this one. So route count. This query shows the total number of routes available, which is 67,000, around 67,000 routes available in the dataset. So this one, route count by airline. So if you see here, this query responds with the number of routes available based on each airline. For example, Ryanair has 2,400 routes, whereas American Airlines has 2,300 routes. So basically, it represents the connectivity specific to airline. And now let me see that one which was loading. Okay, it's loaded. So basically, flight travel grab based airlines based on country departed from and arrived at. So basically, this is the query. Firstly, I'll show you the query. So this is the query. Like we are just mapping the airlines, routes, countries departed from and arrived at. So this is how it looks. So I've limited the by default the number of nodes limit was 300. I raised it to 1,000 just to be on the balance of having optimal time and to visualize a significant number of nodes. So in this graph, there are four type of nodes. You see here, airline, country, airport, and route. So along with relationships like based in, located in, arrives at, departs from, operated by. So arrives at, departs from, the flight will be departing from a particular airport and arrives at a particular airport. And located in relationship is being used for the airport located in a particular country, that one. And operated by is basically is used to represent the relationship between the route and the airline which is operating on that route. Let me show you an example, visual example. So if you see here, this is Dubai airport. Okay, And let me let's start with some route. Okay, so let's take this one, 767. Okay, 767 is a route. The source airport is NBO. You'll be able to see on your right. And 767 is operated by 767 is operated by KLM Royal Dutch Airlines. So this is one of the relationship example between operated by and the route. Okay. And if you see here, this one is the airline. So airline, also we can just move the notes here and there to see better visualization. And if you see here, Air Serbia is based in Serbia, the country. And then Serbia is based in Air Serbia is based in Serbia. And then it is located in, so basically in Serbia, Belgrade Nikola Tesla Airport is located. This airport is located in Serbia. And we can take this one. Let's take, okay, basically the what I'm trying to tell you is, what I'm trying to show you is the relationship from of the route and the airport basically departs from. So if you see here, Belgrade, from Belgrade airport, this relationship is showing that a particular route, this 73H, has been departed from that Belgrade airport. Okay, and then it is being operated by, it is being operated by Iman, sorry, it is operated by Fly Dubai. And then yeah, and the destination airport is Dubai. So if you see here, a lot of yellow lines are there, right? Arrives at this route, arrives at Dubai. So DXB. Okay. And then, so Dubai is located in a country, and sorry, this airport is located in a country, Dubai. So that will also be located as in mapped with the relationship of located in. Okay. So going forward, this is other query. It'll take a minute. So now the query has been executed, and you're able to see the graph, knowledge graph. Now let me zoom in firstly. So basically, this query is different from the earlier one which we saw because it has multi-hop query statement. Like basically, without any constraint, the query can hop from one node to the other node. Likewise, it can hop until fifth hierarchical node. Let me explain in deep. So basically, this graph has nodes like airport, country, and route, along with the relationships like located in, arrives at, and departs from. Okay, now let's see. Now let's take an example. Okay, let's take this route 388. Okay, so this route, or let's take this one. Okay, 77W 333. Okay, so this route departs from Singapore Airport, which is located in Singapore, which is located in Singapore. This relationship. So basically, this relationship thing located in Singapore, and now let's see on the other side. So consider like in Singapore, from Singapore airport, this flight has been departing from and travels through this route 77W 388 or the this one, both are almost same. So I'm just trying to move the, yeah, here it is. Okay, so here if you're seeing this one 77333, so it has source airport as SIN, which is Singapore, and the destination airport is DXB. DXB is Dubai airport. You're able to see the DXB here as well, the code, airport's code, and its name is Dubai International Airport, and it is located in Dubai. So basically, this is the hierarchical flexible hops. There is no restriction in this query in terms of hopping to a specific node or such that. So basically, it can traverse through any nodes until fifth hierarchy. So we'll be able to see a lot of relationships, like the blue ones are departing from. Let me show you here. Yeah, the light brown nodes are the countries, pink ones are the airports, red ones are the routes, whereas the dark brown relationship line is located in, which shows where the airport is located, whereas the yellow one shows the arrives at relationship. Basically, a flight arrives at a airport and departs from is in blue color. You are able to see the blue color, which shows where the flight is starting from. So this is the whole knowledge graph on airlines data set. So this is all about the airline dataset, which we used using Neo4j to explore the insightful information. And yeah, thank you for your time. Hope you liked the video. Thank you so much.